why don't all the people just look exactly the same?
Yeah, why don't I look just like you?
Yeah, we're the same species, right?
Yeah. Probably something to do with genes in there somewhere.
Ah, yes, the biology part.
Yes, we're not related, so I reckon that's quite a big factor.
It is.
So that's good.
So, genotype is what we sum it up as.
Yeah, and think about it as being different genes. We'll have different parents, we'll have different genes there.
Yeah, entirely different families. You probably know that you have similar characteristics to your cousin or your great-granddad or whatever.
So if your parents are quite tall, you'll probably be quite tall as well.
But
yeah,
there is other things that affect it as well as your genotype. Otherwise, why doesn't all your family look exactly the same?
So we have the example of, say, identical twins.
Yeah. So you've got two identical twins. You love this one more.
Yeah.
What if you feed this one more than this one? I know that's just child abuse, don't do that. But if you did...
Yeah. One would probably grow taller than the other because there are nutrients there.
Exactly. So we can sum that up as environment. If this one can grab hold of more food than this one can. If you've both got tall parents, you both have the potential to become tall children. If you're twins, equally tall children, roughly.
Yeah.
But if one of them's got much taller, we can say that it's not all this genotype thing.
Yeah. And these two things come together to form what you look like.
And we have a name for that.
We do, and we call that phenotype.
Absolutely. Not with an F, with a PH.
Yeah, because it's really cool.
Yep, so phenotype is what you look like. It's the characteristics you display.
Yes. And that is made of these two factors.
It is.
So you think a bit more about this factor, I think, Wyn.
Okay, so genotype.
Yeah.
So the things passed on to you. Eye colour is a good example for a second. We think about the genotype and the genes and what codes for what. And your eye colour, say, as an example, might be made of an allele passed down from your parents.
And these are things that are on your chromosomes, which are part of your genes.
If we draw chromosomes as really weird bananas.
That's good.
They're in pairs.
They are in pairs, and there'll be different alleles, and they'll line up at different places, and this will what will cause your different genes.
Absolutely. So say here, this blue bit,
Yeah.
this is what is causing, say, blue eyes on you, if you have blue eyes. Your eye colour.
Yeah.
And it's passed on from your parents. We have a name for this area that they line up with each other. They locate in the same position.
And we call that one loci or loci.
Absolutely.
And that's where they line up, but it might not just be on one chromosome that you have a characteristic.
It might not. Say eye colour perhaps is made up of more than one allele. And there was one down here with another loci. And both of these sort of act together to produce your eye colour.
Maybe even on different chromosomes, and this is called polygenic.
It is. So if there's more than one allele producing one thing, that is polygenic.
And that could be, say, hair colour, maybe eye colour, that sort of thing.
Yep. If there's only one allele, it's monogenic. These are lots of new words.
Yeah, these are keywords you might have to say what mean.
Absolutely. So, those are some new words. Well done.
Yeah.
Now we're going to have to take a jump back a second to GCSE maths.
Yeah, and two different types of data.
So, there's continuous data.
Yes.
Which I probably can't spell.
But, yeah, this is data that is continuous, we'll get into it in a second, and there is discontinuous or discrete data.
There is indeed. So, probably spelled continuous wrong, don't worry about that. Continuous data is spectrum, so you'll be within a spectrum. And an example is height. If we had height across here against number of people, I'm just going to put NO.
Yeah.
Number of people.
Okay.
We'd find something like this.
Yeah, because a lot of people, the average height will be somewhere in the middle, some will be much smaller, and some will be a lot taller.
Absolutely. So what you've got to notice is the average is here, because there's the most number of people have X height, and that will actually change per country if you want to be really technical. Some people are dwarfs.
Yeah.
And about the same amount of people are super blooming tall.
Yeah.
And those are your basketball players.
They're pretty good at basketball.
Another example is mass. You can have quite a varying mass, depending mostly on environment and the amount you eat, but there's certain genetic things.
And it's all about the scale you use for it, so you could be 3'10", or you could be so many inches, or you could be so many millimetres, and you can keep going out like this.
Absolutely, and if you're measuring in millimetres, a really small distance, you're going to have a lot more variation overall.
But if you have something like blood group...
There is 4 blood groups.
Yeah.
There's A, B, and O, I think. And you can't mix them up. You can't be a little bit of AB and a little bit of A. You are one of the 4 distinct blood groups. And that's discrete. It's sort of definite things. Another example is sex. You are male or you are female. That's another discrete thing.
Yeah, so you can't be like a scale of 1, you are this, or you are this.
Absolutely, so that's discrete data.
Mhm.
We did that sort of thing in GCSE, but it's just worth mentioning
Yeah,
that it comes up.
you have to keep that sort of thing in mind. And you can use that sort of thing when we look at graphs predicting stuff.
Absolutely. So,
If we have a graph and a burger.
so if we had a graph of age
Yeah.
against a number of people,
That maybe are at risk of a certain thing.
yes, so what they like to do is stuff like throat cancer or
Mhm.
things like that. So let's say number of people at risk of, we'll say throat cancer.
Okay.
I'm going to put TC, throat cancer.
Yeah, so if you just have age, this will go up as you get older quite a lot.
What if I gave you that graph?
Okay.
What would you draw? What conclusions would you draw from that? This is what Trip just said.
Yeah, I'll say that as you get older, you're more likely to get throat cancer.
Absolutely. And this probably has some values. So in a
Mhm.
question, if this was say 30 years old,
Mhm.
you'd probably say risk until you're 30 is 0, which of course isn't true. I'm making
Yeah.
this up, but
And it exponentially increases, say, after that. But what if we had extra factors?
what if we had alcohol intake?
Mhm.
So it stayed sort of like this, and then it shot up
So
here.
we say that's maybe 1 drink a day.
1 a day.
Um,
So I've got 1.
Yeah, and then maybe this is 2.
And I don't have any other colours, but you have exciting colours.
I do. Maybe this is 1,000,000.
6.
Yeah,
6 a
6
day.
sounds better.
Suddenly we can draw a new conclusion that the amount of alcohol you take per day increases your risk.
Mhm.
You can also say it increases your risk earlier on than you would have a risk if you didn't drink.
Yeah.
Again, we're making this up.
Making this,
entirely.
it might not be quite right. But if you just had one factor, it changes quite a lot. So there's so many factors, it's hard to draw one conclusion.
Absolutely, and that's the point to take away, is a lot of things can contribute to one thing.
Yeah.
So smoking, lifestyle, where you were brought up.
And your genotype will have effects on your likeness to get something.
Absolutely. So someone who lived by the seafront with beautiful fresh air and someone who lived near a steelwork emitting lots of terrible things,
Yeah, there's
probably
about-
different risks of stuff.
In your exam, you might say, might ask you, why can't you just say this is absolutely true? Because of all the different factors.
Absolutely. So that sums up this video. It's a little
Yeah.
bit maths, a little bit interpreting graphs sort of things,
Mhm.
but there's a few new words at the
Yeah.
start there.
And often there's a lot of marks for these graph stuff at the end.
So I think we should go participate in a study
I think
of
we should.
what's the relative risk that we get addicted to tea.
Oh gosh.